tilde beta H gamma tilde, which is a function of sigma tilde, and this if I write as H alpha beta plus delta H alpha beta plus order higher order terms, then I can extract that delta H alpha beta would be this would be gamma zeta, then gamma H alpha beta plus del alpha zeta gamma H gamma beta plus del beta zeta gamma H alpha gamma, and this would be written as del alpha zeta beta plus del beta zeta alpha. Here del alpha of zeta beta, this is the covariant derivative of zeta beta, this is del alpha zeta beta minus the here I might like to remind that when this just reminds me that you might be wondering that for in our Polyakov action which we write, we are usually writing del alpha of x mu, del beta of x mu, eta mu nu, kind of a term. And so you might wonder the presence of del alpha and del beta here, okay, and not of the covariant derivatives. So I just like to explain, this is here delta alpha of x mu sigma alpha, this is just the same as del alpha x of x mu of sigma alpha. This we need to remember. Why is it like this? It is like this because this guy x mu is independent of the indices alpha and beta, and therefore for the worldsheet this mu vector x mu is a scalar. From the perspectives of the worldsheet, this guy is not a vector, it's just a scalar. It's a mu vector for the space-time manifold because it has index mu only. It does depend on sigma alpha. It is a function of tau and sigma is another thing. So, but x mu itself does not depend on the index alpha or beta. And therefore here the covariant derivative is the same as the partial derivative, right? However, here because this zeta beta, this is a proper beta vector, it's a proper 2 vector in the worldsheet space. It has 2 components. Zeta alpha is zeta alpha out of sigma, zeta 0 and zeta 1. So it has 2 components. Okay. So zeta is a 2 vector in the worldsheet space. Of course, this is a scalar in the space-time manifold because it has no index mu. Okay, as long as we can keep this, some people prefer to denote this indices alpha beta. Instead of alpha beta, they prefer to denote it by AB. I'm a little bit more used to alpha and beta, and many texts they use alpha beta, so I thought I could stick to alpha beta. Okay, but we are always discussing them. So whereas the mu is an index of the space-time manifold, right? So all right. So here under this delta x changes like this, whereas delta h alpha beta or h alpha beta changes like this or like this. Here this zeta are gauge parameters of the theory. All right. So here these are the transformations resulting from the invariance of the theory under the reparameterization when sigma goes to sigma tilde. Okay. So when this is the reparameterization and it's a local symmetry and it depends on tau and sigma. So this is the proper gauge symmetry of the theory. String gauge symmetries are determined by this. And here I have 2 gauge parameters. So 2 gauge degrees of freedom I have here. Now we would consider one more another symmetry of the worldsheet, which is called Bile invariance or Bile symmetry, which is the local conformal symmetry. Okay. All right. Good. So then I could remove this. I still keep this, but this I could remove. Yes. So the second of the worldsheet symmetries is the Bile invariance or the Bile symmetry, and this is a local, also a local, the earlier one was also local, conformal symmetry. Here delta x mu is simply 0, so x mu does not change. However, h alpha beta changes to, goes to h tilde alpha beta, and this is equal to, so I can write it in 2 different ways, as this times h alpha beta or as exponential of 2 omega h alpha beta. This capital omega is exponential of 2 omega, and this omega is a function of this. So you could write it either as this or as this. there is only one difference here. Now I could expand this, and if I write it as exponential of 2 omega, I could write it as 1 plus 2 omega plus higher order terms times h alpha beta, and this I could write as, so h alpha beta plus two omega plus order. Here little omega is also infinitesimal quantity, and so its higher orders and they would be neglected. Now this, if I write it as then I could write delta H alpha beta equal to 2 omega into H alpha beta. I could collect the result a little bit on the other side. However, let me just again re-emphasize one particular point. What is the main difference in these two forms? This is the finite form of the transformation, and this is the infinitesimal form of the transformation.